The next topic I wanted to cover was modules in Python, how to use them. So let's start with how to import modules. So the concept of modules is quite simple. So I showed you that many functions and types and things we want to do are already built into Python, and you don't need to do anything just to use them. There is another class of kinds of stuff that you might want to use that are built into the language, but they, for some reason, decided to put them in a separate module. So it won't be available to you by default. You will need to explicitly import some module which contains this functionality, and only then you will be able to use it. And yet there is another class of things which are not even built into the language, and you will have to actively install some third-party library to use it. Okay? But now we deal with kinds of modules which are built into the language, like, for example, the random module. So if you want to use such kind of a module, we just use the import statement followed by the name of the module. So import random will import the random module, and then everything within this module we will be able to use. So for example, the random module has a function which is also called random. And when we do random.random, we access the function random, which is inside the module random, which is a function which gives you some random number, which is uniformly distributed between 0 and 1. And every time we run it, we will get a different random number. And like everything else in Python, modules are, what is it? An object, yeah. And we can use it and pass it away, and we can assign it a different variable if we want. So we could do something like rr1 equals random. And every time that we access this variable, it will be just a reference to the module. It will work the same. This is not a recommended way to do that. Sometimes if you want to change, for some reason, you want to change the name of a module, maybe because you have something else which is called by the same name maybe, or you want to shorten it because you use it quite a lot. Sometimes it's the convention to do, like we'll see some examples. Anyway, if you want to do that, there is a simple syntax in Python which allows you to do that right from the beginning. You say import some module name as another statement, followed by the name you want to give it. And now instead of being called random, it's called rr2. And you can just use it this way. Sometimes we don't need everything within a module. We just need some very specific stuff, and we want to access them quite a lot, so we don't want to use the name of the module as a prefix every time we invoke those things. So there is yet another nice syntax which allows you to import specific things from within a module. So the syntax is from module name import something. So here we import the randint function from the random module. This function will give you some random number between two integers. And now when we call it, we don't need to say random.randint, we just say randint directly, because we already imported it out of the module. And every time we run it, we'll get a different random integer. Within the same statement, we can import as many stuff as we want from within a module. So here we import randint, and we also import the choice function. And here again, we use this as statement to rename it. We want to just call it C. So now the choice function was renamed as C. And we can just type C, and it's a reference to this function, a function which basically just selects a random element from within some sequence. So if we give it a string, it will give us one random letter that appears in this string. There is also another way, which is called the wildcard import, using this asterisk sign. So this basically means from random import everything. And now we don't need to state random.something. So everything that is already within the random module, we can just access it directly. And it just works. So sometimes people use it, but I do not recommend you to use this kind of syntax. Because this can create you a mess. So you won't really know what's coming from where. So if someone reading your code, it will not be clear for them where this function or variable, where it came from. Also, like if you have your own variables, which for for some reason have the same name as something that already exists within this module, you can have some conflicts and then it will override each other. So it's very not recommended to do that. It can open a door that leads to many troubles. But sometimes people do it if they are lazy and just want to import everything.
What's the difference between import random as is and import random asterisk?
Yeah, so good question. So if you just import random as is, like I showed at the beginning, this is actually a very legitimate way to do it, and I do recommend it to do that if you want to import a module and then maybe use a bunch of stuff from that. It won't create any ambiguity because now every time that you want to use something within this random, you will have to explicitly state that it comes from the random module. So you will have to state the name of the module, dot, and then whatever you want to get from it. Whereas in the kind of asterisk syntax, import everything, you no longer need this prefix of the module name. You just use the things themselves. And this can create this overriding problem. Any more questions about how to import from modules? OK, so let's see two examples for quite useful modules. First module I wanted to show you is called the sys module, which is short for system. This will provide you all kind of information and operations you want to do with the Python environment itself, with the system of Python. For example, it has a version variable, which is a string, which states the exact version of Python that you're using. So if you're not sure what Python you're using, this can be a reasonable way to figure out. So you can see that this is Python 3.6.5, not the newest version, which was installed through Anaconda. You can see the exact date in which it was built and also some details about the CPU architecture and stuff like that. Also useful is the syspath variable, which is a list of strings. And this it's just a bunch of directories, of paths, in which Python looks for things to import. So every time that you import a module, these are actually the directories within the computer that Python will go through in that order, one after the other, until it detects the kind of module that you want to import. So if you try to import something, and Python tells you there is no such module, a reasonable way to figure out what's going on is to print the syspath and really make sure that this module really does exist in one of these directories. Another quite useful module is the math module, which gives you some mathematical operations that you want to use. So for example, you can use the exponent function to calculate e to the power of something. Or you can just get math.e, which will give you a reference to this e constants. Likewise, you have the math pi for the pi constant. You can use trigonometric functions like sinus. You can have the logarithm if you want. So by default, if you call the log of something, it will be with the base of e, 2.71. So the log of 100 will give you a strange number. Very commonly in biology and in science, we want specifically to use the log 10 or the log 2 of something. So you have specific functions to use these specific bases. But if you want any other base, you can just derive it directly from the log function using the simple log rules that we learned in high school. So dividing log of 81 with log of 3 will give us the log of 81 with the base of 3, which is a 4. E. Yeah. Yeah, in math it's sometimes called the ln function, so the natural base of log. Let's see some useful bound functions, which are functions which are bound to specific objects. So for example, strings. So let's have a string with some sentence. And let's go over some useful string functions, which we can use on a specific instance of a string. So if we have this specific string instance, now that we call this variable dot some function, this will no longer be some global function which is irrespective of any value. This will be a very specific bound function which is bound to this specific string instance. So everything that we do will happen to this very specific string that we define here. So for example, the upper function will convert it to an uppercase and return a new string with all the letters in uppercase. And likewise, lower will give us everything in lowercase. The find and index are sometimes useful functions. They give you the index where some substring first occurs within this string. So if, for example, we look for the, it happens in index 33. Now, find and index do the exact same thing. The only difference between them is what happens if you provide it with a substring that doesn't occur within the string. So find will just give you -1 in that case, whereas index will raise an error. Okay, so sometimes you want that, sometimes you want that. I mean, it depends how you want to use it. So if you think that your substring should happen in the string and that the case it doesn't occur is really unacceptable, then you might want to use the index function. So you will get an error if that happens for some reason. So you know that you have a bug. And you don't want to continue as if nothing happened. You have the starts with and ends with functions with a quite straightforward name that test whether the given substring is the very end or the very start of your string. So it just returns a Boolean result, whether this is the case or not. The replace function is quite nice. It replaces some substring. So every time that as occurs within the string, it will replace it with more than. Just be careful when you use that you really want to change all of the instances. In this case, for example, we had the word was in the sentence, and as was part of the word was, so we got W more than, which is not what we wanted. So here we use some context. We said only if it's with a space to each side, then only replace it with more than to get what we really wanted. An extremely useful function is the split function, which again, you will give it some substring, and this will return you a list of strings separated by this substring. So for example, if we give it a space, it will separate the string by spaces, meaning that it will just give us all the words in this string. So we have the space C space was, and now each one of them will go to a separate string. And this is a quite useful way to parse sometimes input that we get. Actually, space is the default. So if we don't give it an argument, it will assume that we mean to split it by spaces, but we can give it any other string, and we'll get the parts of the string separated by this substring. If we have a long string with multiple lines, we even have a specific function called split lines, which will just split the string by lines. Will give us all the lines of the string, each one as a separate string within the list, which should be really equivalent to the split by the end line symbol, the /n that we saw last time. A more useful string function is which tests whether the string is comprised only of specific kind of letters. You have the isDigit, which tests whether the string is only made up of digits. Again, spaces are not digits, so if we have a space, it will give us false. Even more general, we have the isAlpha, which tests whether the string is made only of alphanumerical symbols, so namely just letters and digits. So if that's the case, we'll get true. But again, if we have some white space, we'll get false. IsLower just tests whether all the letters are a lowercase. So even if we have things that are not letters, like maybe an exclamation mark or digits, then it's still true. But as long as we have a non-lower letter, namely that once we have an uppercase letter, then we'll get a false. And likewise with isUpper, which tests for uppercase string. we have the is space, which tests whether everything is just a space. So what is considered to be a white space is spaces or tabs or the /n, or also something which is the /r, which is sometimes used in Windows. In Windows, sometimes a new line is not just /n, it's /r/n. Okay, so it's also considered to be a white space. But again, once we have something, for example, a digit, which is not a white space, it will give us a false. Another very useful function is a strip, which strips away from both ends of the string. By default, it will strip away white spaces. So if we have something started with some spaces and then more spaces and then other white spaces characters, then calling strip will remove them from both sides of the string, but only from the side. So if we have something in the middle of the string, then this will not be removed. Okay, so it's not like replace, which replaces everything. It just strips from the sides any trailing white spaces that the string might have. And so the default is to remove white spaces, but we can give it any other kind of characters that we want to get rid of. For example, in DNA sequences, it's quite common. You will see that many times you have the N nucleotide marking something that we don't know exactly what it is. And it's very common in many biological databases that sequences begin with multiple Ns and also end with them, because sometimes at the ends of sequences, we're not really sure what there is. So sometimes we might want to strip them away and just remain with the sequence itself that we are sure about. So it will remove the ends from the side. But again, if we have some ends in the middle, this will not be affected by the strip function. Questions? OK. Let's move to some functions of lists now. So suppose we have a list. We call it columns with some columns. So for lists, we have the count function, which counts how many times a given element appears in the list. So for example, the TGT is, it's happening twice in the list, so we get 2. We have the pop function, which pops out the last element within the list. So once we pop out this list, what we'll get is the last element. This will be the return value of pop. This will give us a a TAG here. And then when we print columns again, you see that it was actually affected by these operations. So now it's removed from the list, and we're remained just with everything until the last one. So this could be sometimes useful to, if we want some, on each iteration maybe, to remove some element from the list until we have no more elements. Using it as some kind of a queue data structure, if you know. And we can also pop out an element from any other place. So by default, it will give us the last element. But if we want, for example, the second element, we'll give it 1. And this will remove this element from the list. And we'll remain just with the other elements. Also very useful is the zip function. This is a bit complicated, so focus and stay with me. What the zip function basically does, it gets 2 kinds of sequences. It gets to maybe more, but let's begin with the case of 2 sequences. So I give it 2 sequences. I give it some codons and an amino acid sequence, which is just a bunch of letters in a string here. And now the specific input that I gave it, we have that each element in the codons list corresponds to the corresponding letter in the AASEC string. So the ATG codon is the codon of the methionine residue, and the TGT is the codon of the cysteine residue, and so on and so forth, until we get to the TAG, which is a stop codon marked by this asterisk. Okay, and maybe we want to recover this matching. We want to have some list that matches between these 2 sequences. So if we call the zip function and we give it the codons and this amino acid sequence, it will give us back this kind of list of tuples. Each tuple is a pair with two elements, where the first is taken from the codons and the second is taken from the amino acid sequence. So we'll basically get the first codon with the first amino acid and the second codon with the second amino acid, and so on until the end. Each one will become its own pair, and all the pairs will be stuck into a bigger list that we get. And if you remember, we can convert a list of pairs into a dictionary just by calling the dict type and using it as a constructor to construct a dictionary. And this will create a dictionary that maps each codon to the corresponding amino acid. So using dict over zip of something will create a dictionary that maps each corresponding element in the first sequence to the corresponding element in the second sequence. Okay, so
You can't use directly the dict on the zip.
you can. Actually, you don't need the list here. The list is just if you want to get it as a list. But if you just want to convert it to a dictionary, you can create a dictionary with the zip of the two arguments, and you get what you want. Yeah.
Can you put two lists as an
Yeah, definitely. Yeah, anything that is sequence-like that has distinct elements will work.
It has to have the same length.
Not exactly. So yeah, good question. So I have an example illustrating that. So suppose that now I give it different length. So now in the AA sequence, I give everything but the last amino acid. So now it's by one element shorter than the list. What will it do is it will just continue as long as all elements exist. So it will also truncate the codons to match to the same length. So it will basically take the minimum length among all the things that you give it. Yeah, and so here I showed you that it works for two elements, but for two arguments, but it can work for any number of arguments that you give it. So if we give it three sequences, a range and one list, and then a third list, then instead of pairs, I will get triplets, again, as tuples, okay, with the first element from each one of the three sequences, and then the second element from each one of them, and then the third one, and so on, okay? So I can give any number. A quite similar kind of function that people often use is the enumerate function. Okay, so what the enumerate does, you give it some list, and it again, like zip, it will give you some list of pairs as tuples, with the first element in each tuple being just its index. Okay, so it will simply stick in the index of each element. So I'll get 0 with the first element, and then 1 with the second element, and then 2 with the third element, and so on. This is exactly like zipping with range. So if I were to zip codons with range of len of codons, I would get what enumerate does, okay? It would be the same. Okay, so I showed you zip and enumerate, but now you can ask, okay, what is it actually good for? Why would I want to use that? So let's see some examples. Let's begin with enumerate. Why would I want to enumerate over something? And the reason is quite straightforward, that sometimes I want to get the index of something as I iterate over it, say in a for loop. So by creating this for loop, which iterates on not on codons, but on enumerate of codons, I can now get both the index and the element itself in just one line, and then just print everything together. Okay, so sometimes we want both the index and the element, and Python lets you do it in a very convenient way. In other programming languages where we do not have this feature, we need to first iterate on the index, and then we need to use the index to extract the element that we want. So we need to do more operation and deal with some indices. But Python gives us a very easy life. It's very convenient. We hardly ever need to use raw indices in Python. Almost always we can avoid using indices, which is a good idea because it's much more elegant and simple, and also removes a lot of complexity because indices is quite complex many times, and it's very easy to get confused when we use indices and create some bugs. So if we can avoid using indices and just use simple for loops, it's always better to work in this approach. And Python allows us to do that. Okay, so by the way, I think this is the first time that I show you this kind of syntax, that for loop, I can provide not just one variable, which is what I put each element in the list, but I can provide multiple variables. And when I do something like that, what I actually mean is that I expect this list to be some sequence of pairs. So each element, I expect it not to be just one element, but a pair of elements. And then Python, with this kind of nice syntax, knows to put the first one in the first variable and the second one in the second variable. I can also create it with my own list, or I can do something like for A, B in a list where the first one is, let's say, 1 and 2, and the second one is 3, or insert, 3 and 4. Yeah, and then I can maybe print it. I can write, A equals that, and B equals that. Can give both of them. Okay, and what this kind of syntax basically does is each time we iterate, we get to a pair, and then just Python knows that the first one is to go into A, and the second one is to go into B. It's very like when we do it with the assignment statement. So when we do something like that, Python knows that the first one is to go into A, and the second one is to go into B, and I already showed you that it has to match. So for example, here, if I have too many elements, I will get this kind of error saying that it's too many values to unpack. So it must match, but as long as it matches, I can use this kind of nice syntax to iterate through it. And that's exactly what you see here. So enumerate gives me this list-like return value of some pairs. And each time I take the first and put it into I, and the second one and put it into column. I can even combine the two methods, the two functions that I showed you. So I can use enumerate over zip of, say, two lists. And what will now happen, again, enumerate will give me the first variable, will always be the index. And the second now it will be whatever zip gives me. And zips give me a pair of two elements. So now I can take this kind of pair and break it down using this syntax. So taking the first one, putting it into codon, and the second one and putting it into the amino acid. And now I can print all three of them, the index, the codon, and the amino acid in one line. Yeah, but actually there is an even simpler way to do it. And again, this relies on the fact that when we do this kind of assignment, we can even create even more complex patterns, like you see here. So here on the right side, I have a list of two elements, where the first is just a number, and the second is itself a list with two elements, each of them a number. And I can actually extract all of them by providing the exact structure that I see on the right-hand side, by providing it on the left-hand side. So what I say is that I want the first element to go into A, and the second element, which I recognize to be a pair of elements by using these parentheses, within this pair, I want the first to go into B and the second go into C. And as long as the structure of the thing on the right-hand side matches to the structure on the left-hand side, Python knows how to make this extraction in a meaningful way, and I get the content of what is inside the right-hand side. So I can now use the same kind of trick within this for loop. Okay, so now I know that enumerate over zip will give me a list where each one is a tuple, where the first is the index and the second is itself a tuple, with the first a codon, the second an amino acid. So I provide the same kind of structure using these parentheses in the for loop, and then it knows how to extract it properly. It knows that the index needs to go into I, and whatever zips give me, the first of each of those needs to go into codon, and the second needs to go into amino acid. And I simply extract everything using just one line of code, and then I can just use it without more processing. Okay, so this is a really nice syntactic sugar that Python gives us to make it very, very easy to work with multiple sequences together that we know should somehow have matching index, but we don't have to explicitly use this kind of indexing. So in most programming languages, in order to do something like that, we would have to iterate over some index. and then using the index to extract the element from the first list, and extract the corresponding element from the second list. And it would be a lot of indexing, but Python just spurs us to do that all together, and we just get everything in one line of code. Okay? Questions? Okay, let's quickly go over the next topic, which is sorting. Okay, so suppose we have some list with numbers, and we want to sort them by value. So Python gives us a built-in function to do that, which is called a sorted function, which will give it some list, and which will give us a sorted version of this list. Okay, so we'll get everything sorted from the smallest to the highest number. If we want it in reversed order, we want to begin from the highest and go to the lowest. We can use the reverse keyword, which is by default false, but here we override it to be true. And now we get it from the highest to the lowest. Of course, when we use this sorted function, it doesn't really affect the original list that we began with. Okay, so if I print values, you see that it has remained with the exact same order that I defined it to be at the beginning. So the sorted function didn't really affect the original list. It just gave us a new list with a sorted version of that list. Sometimes I want to perform operations in place. So I actually want to change the original list that I began with. In that case, instead of using the sorted, I can just use the bound sort function, which will do the exact same thing, just in place. So now it will actually change the list values and will force its elements to be sorted from the lowest to the highest. Sometimes we want to sort a list, but we don't want the default kind of ordering that Python has given us. For example, in the case of numbers, the default ordering is quite straightforward, just which is bigger than which other. But what happens if we want to, say, sort the lists by their absolute value, not the original value? So Python allows us to do that in a very flexible way by providing the key argument, which is expected to be a function. Okay, this is an example of what I showed you at the beginning of the class of cases where it's actually useful to define a function that gets another function as an argument to somehow modify the behavior of the original function. So this is a very classical example of something built into Python. They designed to behave in this way. So the key argument will get any function and use that function as you can think about it as the key of the sorting, okay? So when deciding which is higher and which is lower, it will use this function on top of the elements, and then compare the return value of this function on these two elements. So if we give it the ABS, the absolute value function, it will calculate the absolute value of two elements and only then decide which is bigger and which is lower, okay? So now you see that we sometimes get positive numbers, sometimes negative numbers, but the absolute value is increasing. And again, this can be combined with the reverse to get it in reverse order. Questions about this? Okay. Sometimes if we have a list of other lists or a list of tuples, the default behavior in Python is to, when deciding which is bigger and which is lower, is just to look at the first element within each tuple. Okay, so when comparing a tuples, the effective element will be the first one in each tuple. So 5, 0 will be bigger than 3, 4 because 5 is bigger than 3. So the fact that 0 is smaller than 4 is irrelevant here. The second element will only be taken into account if we have a tie in the first element. Okay, only then it will compare the second element and so on and so forth. If for some reason, say, we want to change this behavior and we actually want to make the comparison in the other way. We want to begin with the second element, actually, and we want the second element to determine which is bigger and which is lower. we will basically have to give it our own function. So here we define a function that given a pair will actually give it the second value. And then we can give this function as the key argument. And now every time that it compares two elements, it will use the getValue function to get the second element of each pair. And now you see that it's sorted by the second element. But because the getValue gives you only the second element, it means that the first element will be ignored altogether. So now it will no longer be used to break ties. Okay, so if we have two pairs with an equal value on the second element, then we'll just get arbitrary ordering between them. Okay, if we wanted to compare by the second and then by the first, we would have to modify the getValue to also give the first element. Okay, so we can just basically replace the order and give it another tuple, and now it will give us this kind of the first element being used as a tiebreaker, and when we have a tie. When we compare strings, so the default kind of ordering is what is called the, I think the lexicographical ordering, it's sometimes called. It's like the kind of default ordering that you see in dictionaries. Basically taking the first letter, and only if the first letter is equal, look at the second letter, and so on. This will be the default ordering in which Python will consider strings. But again, we can modify it if we want. For example, if we want to modify, we want to sort the strings by their length, we can use the len function to then get the length of each element, and then this will be used as the ordering of the strings. Okay, any questions about how to order, sort? Okay. So I don't think I'll get to finish it, but as far as I will go before the break. Okay, let's now speak about, again, a very important topic, which is how to work with files. And this is very important because up until now, we didn't really show you how to get some data into your code. We basically, if you wanted to work on some data, you needed to type it, hard code it into your code. For example, when working on a DNA sequence, you actually needed to type that DNA sequence as a string. But of course, that's not really feasible to do in most cases. So if you want to work on a large chunk of data and you want to somehow load this data into Python, there is no way around it. You will need to somehow get this information from an external source. And the most common way to do that is to this external source being just a file on your computer that you want to open. So very often it's just a text file, like in this example. So here I put in the Moodle, you can download it, an example file, which I called breca1.txt. I downloaded, I think, to, where is it? Yeah. Okay, so yeah, I put it here in downloads. But here I expect it to be in C downloads. Okay, so let's create a directory. One moment. Okay, so I go to the C drive. Here I create a new directory. I call it downloads. And then I take the breca1 and put it here. Okay, now it should be accessible. So let's first maybe inspect this file and see what's in there. Okay, so I use this nice editor, which is called Notepad++, which I think is better than the default Notepad to view files. So you can just, on your command prompt, you can just write Notepad++, and it will open this kind of software. And I can just take this breca1 file and drag it into this editor. I will zoom in so you can see what's in there. Okay, so this is a quite simple text file with some details which I took from RefSec, which Michal showed you today, of that BRCA1 gene. And I didn't take all the details, just some basic features. So I took the excision, you can see the RefSec ID, the organism, it's the Homo sapiens, and the definition, you can see it's the BRCA1 gene, transcript variant 1, mRNA associated with BRCA1 of the Homo sapiens. And then just as features, I just took all the exon coordinates. So you can see basically the lengths of all the exons that this gene is comprised of. And if you hit this kind of symbol here, which is show all characters, this kind of twisted P shape sign, then now you can also see the white spaces in this file. This is very useful if we then go to parse it and to try to process this data with Python. We want to actually see what this is made up of. And you can see, for example, that these spaces here, it's not really spaces. This is a tab. So each one of these is just one character, which happens to be a tab. And you can see the /r/n at the beginning, at the end of each line. And you can see all the white spaces. So now you can actually see what this file is made of. OK, so let's get back to the notebook. So suppose I want to open this file and extract its text into Python. So to do that, I use the built-in open function, which just gets some path of a file. So everything, including the drive, the directory, and then the file name itself, including, of course, the extension, which is part of the file name. And then I give it an R, which is what is called the mode in which I want to open this file. R means that I just want to read it. I will later show you how to write files. But now we just want to read a file. And by the way, it's very important to note this R at the beginning. Who remembers what this R means? Sorry?
Regular expressions?
No, this is not a regular expression.
Raw?
Row, yeah, right. So a row means that every time that I put a backslash, I literally mean a backslash. I don't want it to be interpreted in some way. So because in Windows, I mean, not in this case. Here I just use forward slashes. But in Windows, sometimes you will get backslashes. It will give you as part of the file names. And then if you don't put this R at the beginning, it might think that if you have some backslash something, it's supposed to mean some special characters, maybe. But you don't want that. You don't want to deal with escaping and stuff like that. So when you put paths of directories or files, especially in Windows, I strongly recommend you to use this R at the beginning. Otherwise, you might have this kind of non-escaping behavior, which you do not expect. OK. So once I open the file, I get back a file object, which I put into the f variable. If I just print f, I won't get the content of the file. I will just get a file object. And you can see here, it gives me just file object with the path and the modes and some other details about the file. If I want to actually read what's within the file, I need to call the read function, which gives me back. It reads the whole content of the file and will give me the content as a string. OK, so now I print it and I get actually the content of the file. But do pay attention that the read function, actually what I want to say is that the file object is what is called a stateful object. It has a state. So every time that you call the read function, it changes the state of the object. And now, once I read it once, I cannot reread it again unless I do something. OK? It marks it in the object as if it was already read, and it remembers that it was read. So read will just give me everything that wasn't read yet. But if I already read it, then it will just give me nothing, because there is nothing left in this file. So do pay attention that unless you do something special, you can only call read once. OK? So you won't get it again every time that you read it. So make sure that you keep everything that you need on the first time that you read the file.
Sorry, why can't you use the files again?
Again, because this has this internal state. It remembers what you read already. And when you call the read function, it gives you only things that you have not read yet. But if you just call the read and to read everything, then it's already read in some sense. There is a function, I'm not showing it to you here, maybe I'll cover it in a future lesson. There is a way to tell Python, okay, I want you to go back maybe and give me some earlier thing that you already read, but it's more complicated. And that's not how it behaves by default. Okay? Okay, and final thing before we go on a break, it's very, very, very important. Never forget to close a file. So when you're done with the file, once you've read everything that you want to read, make sure you call the close function to close it. Again, because if you don't do that, it might create you problems. This is especially true when you open a file in writing mode. So if you do that, there is some kind of a locking mechanism, which allows only one software at a time in most operating systems to open a file. And if you do not close it, then this file will be considered by the operating system to still be busy, and it will not let you open it again. So to avoid all this trouble, just make sure to always close the file. And in future lessons, I will show you a more convenient way to make sure that you close the file, but for now, just manually make sure to do that.